Okay, today's notes are going to be over scatter plots and finding a trend line, but this time we're not going to find our line of best fit by hand. We're going to use the calculator. So we're going to practice using the calculator and identify the linear regression for a scatter plot. And we're also going to be able to identify the correlation coefficient. Correlation coefficient is the R. This tells us how closely the equation models the data. So you see how we have these scatter plots and our points are not exactly on this line, this trend line. So it's not an exact equation for the type of data here, but our R here is going to tell us how closely the data is related, whether it's spread apart, which isn't as close as the correlation would identify. So right here, your R is going to represent when it's a negative one, it's a negative correlation. It will be going down. When it's exactly one, our positive correlation going up. It's a positive slope here. It's going down. When it's zero, that means our data is all over the place and there's no correlation between the data. For example, your shoe size and the length of your hair, that would be no correlation. So the closer you are to one, the stronger your positive correlation is. So if we had 0.5 here in the middle, that would be a weak positive correlation compared to 0.9, where that would be a strong positive correlation. And then the closer you are to -1, the stronger your negative correlation. So if I had a -0.8, that would be a strong negative. If I had something like a -0.4, that would be a weak negative correlation. So let's go ahead and look at the calculator and practice identifying some correlations and putting this into the calculator to identify the linear regression. Okay, so here are our notes for today. In our notes, give me 1 second. Let me go ahead and pull up that pencil again. We are going to practice using the calculator. Okay, here are our notes. So we are going to take this table, which represents the amount of time students in a class studied for a test and their test scores. So here my hours studied are my X's, my test score are my Y values. So I can see here on the scatter plot where those points lie. They look a little further apart. I could draw a trend line through my data and try and come up with this equation myself by hand, but if we use a calculator, it would come out a little bit more accurately, and we're going to be able to do that today. So that's what I'm going to show you right now. How to take this table and enter it into the calculator to find our linear regression equation, our correlation coefficient, the type of correlation, and we're going to use that to predict. Okay, so let me go ahead and pull up my calculator. So when I pull up my calculator, I'm going to see that I can enter a table on my calculator. So what I'm going to do is take my notes and enter the table that I have here. So I'm going to make this a little smaller and have it next to my screen here. So if I'm going to enter a table, what I need to do first is press the plus sign here to add an item. I'm going to add a table and it automatically has X and Y. So from my table on my notes, I'm going to enter my X values, 1, 0, 3, 1.5, 2.75, 1, 0.5, and 2. Then I'm going to enter my Y values, 78, 75, 90, 89, 97, 85, 81, and 80. After I enter these values, I am now going to use the calculator function on the next line. If I click here, what I need to enter is y1 and then approximate it to m times x1 plus b. So if I use my keyboard and type y1, it automatically makes the subscript for me. If I need to enter, so we need to get the keyboard to appear. And once you click the keyboard, what we're going to type is Y1, and then ABC will then allow you to bring in the approximation MX1, and you can just type M and X1 on your calculator, plus B, and because we use this linear regression, we are using Y1 approximated to MX1 plus B, where M and B are going to be your slope and your y-intercept. So what you need from this information is R, which tells us the correlation coefficient, M, which identifies your slope, and B identifies the y-intercept. So if I try and look at my graph, I don't see anything on my graph. So I can zoom out, and there's my line of best fit. If I want to look at this at the scatter plot, I can just focus on certain parameters. So I can use my tool, my graph settings, and I can change the x-axis to be restricted to only 0. And then my x values, looking at my table, I can go all the way to, let's say, 5. So there's my scatter plot closer to my x values. Now if I adjust my y values for my graph, I can look at from 0 for the y values all the way to, let's go ahead and put 110. And so once I do that, I can now see the parameters and this scatter plot a little clearly and see how this trend line falls through my data. So when I notice that my correlation coefficient isn't close to 1, but it's not close to 1 like 0.9, but it's still over the mark of 0.75 or 0.50. So we would be saying that this is a strong positive. It would be a weak positive if our correlation coefficient was anything less than, say, 0.5. M is going to represent our slope. So when we write the equation, we can round to the nearest hundredth. Same for our y-intercept here. Okay, we can round to the nearest hundredth. So if I go back to my notes, I'm going to enter this information here. My linear regression is going to be y equals M is 5.42, or let's round it to 3, x plus b, which is 76.41. So this here would be my linear regression. To identify the correlation coefficient, that's just R. So here R equals, in this case, it's 0.786. The type of correlation we're going to identify this as a strong positive correlation. Now we're going to use this information and we're going to predict a student's test score if they studied for 4 hours. So I'm going to minimize my notes and I'm going to come over here to my information. And now that I know my slope and my y-intercept, I can plug in the value 4 for x and identify what that value is. Or I can type my equation here, y equals 5.43x plus 76.41. And using this information, I can now use the tools in my calculator to pull up a table and look at my table and identify. When my x value is 4, I can predict the score to be 98. And I can do this for any value asked. So if I was asked if we studied for 6 hours, our score would be 108 on the test. If we studied for 1 hour, our score would be an average of an 82. If we only studied for 0.75 hours, our average would be an 80 for the test score. So going back to our notes, we're going to predict the test score by using our equation. And here we are going to predict at 4 hours, your score would be a 98% test score. Okay, so you're going to practice doing this on your own today. Whether you have a table or a graph, you would need to either take your graph and come up with those values from your graph and make yourself a table so that you can enter the table into the calculator. If you have only a table, use your table, enter it into your calculator. Make sure that you go back and watch the notes or use the click sheets to type this in and find your correlation coefficient and write the equation. Make sure you're identifying the type of correlation, whether it's positive, strong positive, weak positive, strong negative, or weak negative correlation. And then use your equation to make a prediction. Lastly, on our notes, we are going to look at identifying the type of correlation it is. So from this type of question, you would want to go ahead and, let me move this over so I can grab this pencil here. So when I identify this to be a certain type of correlation, I want to make sure I understand that the type of correlation goes back to our notes. And when you're looking at the R value, it's telling me how closely this data is related. So here, if I have R equals negative 0.43, well, negative 0.43 is closer to 0, so it's not closer to negative 1. So this would be a weak negative correlation. If we have something like R equals 0.87, well, that's closer to 1. That's showing a strong positive correlation. If we have something like negative 0.95, well, negative 0.95 is closer to negative 1, so this would be a strong negative correlation. If I have something, some data that represents the correlation coefficient as 0.39. Well, 0.39 is closer to 0, so it's still positive, but it is a weak positive correlation. So now you're going to practice on your own. If you have questions, please make sure you join Zoom daily, ask your teachers, and use the homework help online in your student portal.